Junior Cycle Higher Level Edco sample from the 2015 set of papers, sampleC, paper 1, question 11. This is a factorising of algebra question. We're given two terms and we're asked to factorise it. Well, when you have two terms, it'll be highest common factor or it'll be difference of two squares. And actually that's what we got here. This is a straightforward highest common factor, and the second question will be difference of two squares. So we'll go through the first one. What's the highest common factor of 2p squared q and 4p q squared? Well, 2 is common factor. 2 is a factor of 2 and 4. P and p squared, well, p is common factor of p squared and a factor of p, and q and q squared, well, q is a common factor of q and q squared. So my highest common factor is 2pq, and so it's a case of what do I multiply by 2pq to get 2p squared q? Well, it's p minus, what would I multiply by 2pq to get 4pq squared? Well, the 4, to get this 4, I need another 2. 2 by 2 makes 4, and then I've got pq, got the p there. I just need one more q to go with that q there, so it's p minus 2q. So we have two factors. Rather than having two separate terms added, or in this case subtracted together, we have two terms multiplied together. Moving on to part 2, or part B, this is difference of two squares. We know it's difference of two squares. We can sense it. So our system, a little alarm bell should ring when we see things like 25 and 81, which are both square numbers. So 25x squared, well, that is 5x all squared. And 81y squared, well, 81 y squared, so it's 9y all squared. So what I'm finding here is I'm finding what's the square root of 25x squared, and that goes inside a set of brackets which I then square. Likewise, 81y squared, what's the square root of 81y squared? Well, it's 9y, and so therefore I square it to get the 81y squared. So I have two things, this squared minus this squared, so it's the difference of two squares. And then I can use the rule for difference of two squares and say 5x minus 9y, 5x plus 9y. Moving on to part C, we have 4 terms. So generally speaking, what happens here is you take the first two terms, try and factorise them, and the second two terms and try and factorise them. Now, this particular question, there isn't a common factor between these two terms, and nor is there a common factor between these two terms. So maybe I should compare them up in a different way. Maybe I pair them up xy and xa, and separately minus 5a and minus 5y. That's not a bad one, since there you can see connections between those two terms, and you see connections between these two terms. So we'll go with that. Now, just before I carry on, I could have gone with factorise these two terms and separately these two terms, but I'm going to go with the first and third together and the second and fourth ones together. So what do we have for these two terms as a common factor? It's x, and we have y plus a as the other factor. For minus 5a and minus 5y, well, minus 5 is the common factor, and we have a plus y. Now, what we would say at this stage is we actually, these two brackets obviously look different, but they're the same. Y plus a is the same as a plus y. Addition is commutative. So what's inside the brackets is actually a common factor. So we can say a plus y, I'm writing them alphabetically, as a common factor and multiplied by x and minus 5. Moving on to the, we're asked to divide 8x cubed minus 297 by this linear expression 2x minus 3. There's a variety of different ways which we can approach this question. The first way would be to do a straight long division process, and not everyone's favourite, but we'll go through it anyway. So we're saying, well, when I divide 8x cubed minus 27 by 2x minus 3, what do I get? Well, let's just set myself up here for my long division. Now, if you have an empty term, you can see here I've got x cubed and I've got a number, but I don't have any x squared and I don't have any x's. But I should actually say I've got 0x squared, I've got 0x, and I've got minus 27. So what do I multiply by 2x to get 8x squared, 8x cubed? Well, that is 4x squared. And so when 4x squared is multiplied by 2x minus 3, what do I actually get? I get 8x cubed minus 12x squared. Do a subtraction of those two terms, and I get positive 12x. Bring down the 0x. I now have a new expression to divide by 2x minus 3. So what do I multiply by 2x to get 12x squared? Well, that's going to be plus 6x. And 6x multiplied by 2x minus 3 is 12x squared minus 18x. Do a subtraction of those two statements. I get positive 18x. Bring down the minus 27. What do I multiply by 18x minus 27? What do I multiply by 2x minus 3 to get 18x minus 27? Sorry, that's plus 9. 9 times by 2x minus 3. I see when I do subtraction, I get a remainder of 0. So this expression at the top here of 4x squared plus 6x plus 9 is the correct answer. This is not the only way I could do this. An alternative approach is to think of it as a multiplication. So the question is, what do I multiply by 2x minus 3 such that I will get the cubic expression of 8x cubed minus 27? Well, the first thing you do is you say, what do I multiply by 2x to get 8x cubed? It has to be an x squared term, and it'll be 4x squared. And for the last term, what do I multiply by minus 3 to get minus 27? Well, that's plus 9. Now, straight away you can see, without too much work, I've been able to get the first and the last of my answer that is required. The only thing I don't know is what the x term is in the middle is. So, I suppose what I can do is I can say, well, let's call it just px. Now, if I was to multiply this out and do this multiplication, i.e., if I was to multiply 2x by each of these terms and minus 3 by each of these terms, what do I actually get? So I get 8x cubed plus 2px squared plus 18x. I also get minus 12x squared minus 3px minus 27. So we now compare what we have on the left-hand side with what we have on the right-hand side. So 8x cubed, that's fine, minus 27, that's fine. We don't have any x squareds next term, so what we should find is this expression here should cancel itself out. Likewise, to a certain extent, if I look at the other term we've got there, these two terms should cancel each other out. So we have 2p and minus 12 must equal 0. So it doesn't take long. We find p is 6. Alternatively, instead of that, what I could have done is said, well, 18 take away 3p is equal to 0. And eventually I would have come up with the same answer. P is equal to 6. So it doesn't really matter which way it goes. Suffice to say, so in terms of what I was doing here, I was saying, what do I multiply by 2x minus 3 to get this cubic equation? I get 4x squared plus 6x plus 9. So my answer is 4x squared plus 6x plus 9. So the same answer, but just got in a completely different way. The first way I was thinking it as a division. I was chunking this expression up, taking how many lots of 2x minus 3 can I take away from this expression. And the second method, I was just doing it as a multiplication. A final method that could be used to approach with this question is if I think of the grid method for doing factorizing or multiplying out brackets. I'm saying to myself, what do I multiply by 2x minus 3 to get 8x cubed minus 27? Well, what I can do is I can say, right, what do I multiply by minus 3 to get minus 27? Well, it's going to be plus 9. But what is 2x multiplied by plus 9? Well, that's going to be plus 18x. Well, I need to get rid of plus 18x, so let's find a way of getting rid of 18x. Well, let's subtract it. So what do I multiply by minus 3 to get minus 18x? I multiply it by plus 6x. Just to make sure we finish it off and it all works. Since I have 2x and 6x, I need to multiply them together. So I get 12x squared, but I need to get rid of 12x squared, so I subtract it. And what do I multiply by minus 3 to get minus 12x squared? Well, I multiply it by 4x squared. And there's my solution that way.